Okay, so you see the package from the Droplet Lab?
Yeah, I'm excited to open it up.
Well,
Shall we?
go ahead then,
Please.
since you're so excited.
Yep.
Oh, that's the phone, the heart of the whole matter?
Yes, and that's a Google Pixel. It's just a
Smart
Google phone that's going to be doing all. We're going to be doing all the. We use the app as a camera for the calculation as well. So that's going to be our
Put
phone.
the box away, so. All right, so I hand to you the syringe, right?
Exactly. This is the gas tight syringe, and I got a couple of them here, and they have the screw here for precise diffusing, and yeah, we got a couple of them.
Needle later on top, right?
Exactly. So this is going to be for dispensing the liquids, and we have the base plate. That's the main one. So we have these two lines here. We're going to attach everything on it.
Okay. So let me give you the light source first.
Okay, so this is the light source. We're going to do backlighting to maximize the contrast. So you can just use this backlight. You put it, maybe you fix it in this side.
And you put this or no?
Well, this end is going to be the backlight, and the other end will be the camera. So you just want
back end, you can put the light there as well.
You can put it either or. You just have to have them facing each other, and it's very easy. Here, magnetic switches that keeps it in place.
Oh, and you can move it around if you want. It is.
Yeah, you can easily.
And then locks it again in place.
Exactly.
Well, that's very cool. Okay.
Very easy fix. Then we have on the other side, we're gonna have the phone holder. Again, easy fixing here with the magnetics.
Oh, I see what you mean. That you sort of have them face one another.
Exactly.
Either end really doesn't.
Lug it in place. I'm gonna have the phone here. This is the phone holder. I can add it, adjust it this way, and then I have the lighting here on the other side.
I see.
Now,
should I give you the platform for the syringe? I think this is where the syringe.
This is for the manual syringe. So we can have this one also adjusted in between. So we need this mount for it.
I see.
So we can adjust it here.
Right, because I noticed that the automatic one had already the syringe pre-mounted, because I suppose this is more sophisticated system.
That's right. Okay. For this one, it's more simpler. You can just slide it in here and then keep it in place. And then eventually you can add the needle in this mount, of course. So I bring my needle, I can open this up, have the needle in there, and then tighten it.
And hold it in place, I see.
Exactly.
Okay.
That's for the manual diffusing system, yeah.
If you're dispensing, right? So this would be as is for the surface tension measurement.
That's right.
If you would like to do the contact angle measurements, static, advancing, or receding, then you need this stage, right? This is what I saw in the video that they had online, Droplet Lab.
Exactly. This one is the flat stage. Let me move this a little bit here. So we can add this stage, which is just a flat for any Sessile drop measurements. But I can also have different type of stages here.
Nice. It has the level, so you know that if your surface is completely level or not.
You have to level
you can make
surface
adjustments, coarse adjustments here as well for the leveling.
That's right.
Okay.
And then we have different types of surfaces. We have the one that's dedicated for fabric. So this is a fabric stage.
And put the other one in?
That's right. So if you're going to do measurements on fabrics, we're going to need the fabric stage.
The stage, right. And these are, I suppose, that you wrap it around and it locks in place.
Exactly.
These screws here to have the fabric stretched to make a proper measurements.
That's right. Cool. And this one for Sessile. I also know that there is another one for tilting measurements.
Okay, so you can take that out.
Of course.
Let me give you this one. This must be the manual tilting.
Exactly. So this one is going to be also fixed right here, again with the magnet, and then we can adjust the tilting of the stage. Manual.
Oh, I noticed that they also have the motorized version.
You want more precision? We can do it with the automated one. Definitely with the second one.
This the same place?
Yes. We'll need to make room for it.
Yes. Okay, and I see the wire connectors here to get connected to the power. Okay. Yeah. Okay, here. Mount it. Okay, very good. I think that's a wrap. Okay, Ismail. So why don't you do the Sessile drop measurements on some of the samples we have in here?
The setup is ready.
Yeah.
We have the phone holder, the syringe, the table for Sessile drop, and the backlighting. I'm gonna choose the app.
Yeah, choose the Sessile drop app.
Exactly, and we quickly log in. What is the password?
So you can have your individual account there.
Exactly, you create your own account and you sign in, and you have all the projects that saved from before.
Can you start a new project, please?
We're gonna add a new project. You can name it here. Let's name it SEIL. You create your own project name, and then the image calibration. You need to know the size of the outer diameter of the needle in millimeter.
Yeah.
So I know this one is gauge 21. We bought it this gauge, so I know the.
Okay, so
0.812 millimeter, and then the density difference between the liquid that I'm using, which is water in this case, and the surrounding medium, which is air. So the default is this, and then the gravity is taken as default is 9.8, but you can manipulate this just in case. We have to.
We are not the moon yet, are we?
We're not. So we can do automatic or manual injection. Right now I have the manual one.
Yeah,
that's what we did. Automatic is pretty nice. We can start the project, and then we go to the project, and then we start the camera, and then we fix it on the holder.
Upside down, right?
Upside down, because the camera is at the bottom here.
Okay.
And we fix it here and have...
Also, you pay attention to make sure that the needle and everything is there.
Exactly, and what's nice really that there's a knob here that I can move this whole thing, this whole holder, right and left. It makes it very convenient.
Oh, to center the needle.
To center this. So I can actually control this needle separate, or I control the phone holder separate for both at the same time.
Interesting.
Then we try to adjust, play a little bit with the focus to have our needle in focus.
Okay.
Then I have a couple surfaces
here.
here.
Image for the calibration first, or how does it work?
Yeah, so I can take an image. Since I'm gonna do a Sessile drop, I can generate the droplet and then take a picture. And with that picture, I'm going to do the calibration, then the contact angle measurement.
I see.
So I'm trying to now work on the optics.
Okay.
Get it sorted out. So I have a couple surfaces here. I'm gonna put my surface, which is an aluminum.
You're putting the aluminum surface?
This is an aluminum surface.
A
little bit rough. So I'm going to get...
Should you adjust the height for the needle?
Yeah, we can adjust
to the surface.
Exactly. I'm thinking to bring it a little bit closer.
Okay, so you lowered the needle now?
I lowered the needle a little bit, and because you don't want the droplet to actually really fall and impact, and this angle is going to be...
And I see that you leveled the surface here before.
Yes.
No? So you have platform can be leveled down.
Exactly. We got the 4 knobs for the whole table here.
Right.
And you can change the elevation of this plate
too?
with this knob here.
Oh, I see.
So we're going to slowly with the adjustable thread here to create a droplet on the surface.
Yeah, I can see sort of a small droplet forming.
Trying to gently deposit it.
Yeah, I think the size of your needle should be larger than your. Sorry, it should be much smaller than the size of your needle.
Actually the setup here comes with a lot of different types of needles with different outer diameters, so we can actually manipulate that. So now we have a droplet sitting on the surface. I can now adjust this crop box to have part of the needle for calibration and the Sessile droplet as well. I can also adjust the backlighting, increase it or decrease it.
Get a different contrast?
To have a better contrast.
Can you do the same thing in the software as well?
Yeah, so in the software you can adjust the lighting of there's a lighting scrolling bar here.
Okay, so you have 2 possibilities then for
exactly.
Background light or through the software.
That's right. So we're trying to make, what you need to see is a really nice edge, very clear, because this is where the algorithm is going to be capturing. Okay, so now we have a sort of nice picture. We click on this capture button, and then we go back and we start. We can actually take this out as well. And
oh, that's convenient. So you can just hold it in the
so it's portable and
from
exactly. So we can go on the image that we did. We have different types of algorithms actually to measure either polynomial, which is purely geometrical, or we have Young-Laplace, which is going to take the physics into consideration, which is taking into consideration the pressure inside of this bubble, droplet, and how it's being deformed with the gravity. So from the shape, it connects the physics to it.
I see.
So now we're going to calibrate the needle. So
you calibrate it if you use the Young Laplace or only for polynomial?
Yeah, so only for Young Laplace because it's dependent on physical and the geometry. We're gonna need to move from the pixel domain to the physical domain in millimeter. So if you're in polynomial, you're gonna see this is not activated. So make sure that you're in the Young Laplace. If this is the plan, then we are going to have the needle to be around the needle here, and then press calibrate. If it's in green, we're doing good. And then,
nice. So you didn't need to be so precise as well.
Not at all. It's actually just gonna be around it in the proximity, and then it's going to capture it.
Nice.
And then now we go at the surface and we move these indicators on the sides.
This is to find out the baseline?
The baseline with these indicators, and then we click calculate, and now it's trying to solve the Young Laplace equation on that shape of the droplet.
I see. And I noticed that they mentioned they have a new AI version as well, that you don't need to do this step.
Yeah, that's going to be very helpful.
Oh, interesting. So now you've got sort of the contact angles from left and right side using the Laplace.
And in Young Laplace equation, it averages the right and left. But if we're going to use the polynomial one, it actually can have the right and the left accurate.
I see. So both sides going to read then 79.5 in this case.
And for the polynomial, we got different options like manual, where you can manipulate where exactly the lines and the geometry.
Right.
Smart is going to fit a simple equation to the curve. And extended, it fits like a more complicated, more sophisticated equation.
Oh, so that is also have some
there's different options
So
based on geometry. Yeah.
Cool. Very nice. Oh, I like it. So it was easy to work with, no?
It's very easy, very convenient, very versatile, adjustable. Everything here is adjustable, and I think it's very good for the cost of it.
You did the static contact angle measurement, but I know that a lot of standards or a lot of researchers are interested, or people in industry are interested in the advancing contact angle and receding contact angle. Can you do this also to sort of show?
Yeah, of course. This is actually
new toy of yours is working.
It's actually very cool. Like in the same app and the same project that we opened, we can just get in there and we are going to set the camera again, and we can actually do this dynamic
contact
angle measurement. All using the exact same setup.
And you can set up the what timing you have for your images.
So this is great. We took only one image, one snapshot, but this time we're going to use a feature called multi snaps. So I'm going to take a couple of images within a certain time.
A series you can do.
We can do a series. We can do a lot more than a couple.
Okay.
I think the default is like, or the max if you don't have SAT, is 10 frames per second. I guess.
I see.
This is the fastest we can get.
That's more than enough, yeah.
So I try to get the needle close to the surface because I'm going to be dispensing liquid, increasing the size, make it move on the surface.
Right.
That's why it's dynamic. So now I have it set it up, adjust the focus again and the brightness.
Right.
To get the yeah, it's basically almost on the same spot, so we don't have to do a lot of adjustment.
Okay.
Now I'm going to infuse this.
You're dispensing the liquid,
the liquid, and when I'm close, I'm going to start how many images I need to capture within what time duration.
Right.
So I'm going to say, let's say I'm going to have 30 images within maybe 20 seconds or 20 seconds.
Stole my
number. Here you go. So now once I hit capture, it's going to start taking the images, and now I'm going to dispense and make sure that I keep increasing the size so it moves on the surface outwards, so it's advancing, and this is going to be the advancing contact angle. So I just make sure that I have enough
liquid beforehand, right? So you filled up your syringe.
Exactly. That's what I had to do in between.
I see.
So now, what I have now,
over?
It is over.
So automatically stop?
It stops, and then now I can take this out, and I'm gonna have a lot of different images. This is the image set.
Right, yeah.
So I can calculate, I can work on one of them, and then it calculates the rest of the images.
Oh, nice.
So
essentially you take the first one or whatever you want, and it treats the rest of them. You don't need to do anything, gives you all the angle.
Exactly, it takes the same exact settings.
Can you this time for the advancing receiving use the polynomial, because last time for static use the Laplace, please?
I think in that case, since I have the needle inside the droplet, then I cannot really use Young Plus is not going to be super accurate because this basically depends on the whole droplet shape profile. However, polynomial, it focuses on the contact line only.
The region near the contact line.
Geometrical, so I can do it with the needle in or out.
I see. Okay.
So in that
now you
case,
have the needle in, and therefore you would like to have it in the polynomial analysis.
That is right, and in this case, I don't really need to calibrate. I just need to find the contact line, which is
manually here to give it an approximate where it is, right?
Exactly.
And in the future, not in the future, actually in the next, the other version that is available in the AI,
you don't need even to do these knowing steps. And then you go into hit measure, and this is going to be the right angle and the left angle. It does not average it like the angle class.
I see.
So now you have a measurement for advancing contact angle on both sides.
All these measurements that we see in the screen, they are available through a spreadsheet that sort of spits out when we have a series of images like this, right?
That's
so I don't need to record anything, just all get recorded, and I can email it or upload it to a Dropbox or whatever.
Yeah, and that's very, very convenient.
Okay. So just want to let you something. For your measurements, you really don't need to have the connectivity to the internet or anything.
We're doing the whole thing.
If you want to send the information somewhere else.
Yeah.
Otherwise, everything is done locally, right?
Everything is done offline, just on the app. All the algorithms are built in on the app. So I'm doing everything offline, unless I want to upload that onto a cloud so I can access it from everywhere. Then that part would require the internet. Yeah.
Okay. So that's interesting. So we can do all these contact angle measurements to understand the behavior of liquids. But also what we can do here is to get the solid surface energy. For that, depending on which of the methods we use for solid surface energy, there are two different methods existing here.
We see
Neumann's method, Fock's method, or Van Osgood method. We may need to use a number of different liquids. So what it means is you select that method, any of those methods, and according to the protocol for each of these methods, all you need to have the syringes that are filled with different liquids, and you make the measurements on this one and the same solid surface. You'll be able then to get the solid surface energy by using the proper methods and just feeding those measurements for the contact angle exactly as you did right now. So
that is really very helpful.
And I think you use the different app for this, right? You use the surface energy.
I use the surface energy app.
So we have to get out of the Sessile app and the surface energy app.
We have app for each one, for the pending drop, for surface measurement, surface tension measurement, the contact angle, the Sessile, and this one for the solid surface energy.
Okay.
And we have another one for the tilting.
That's nice. So we have four apps.
We have 4 apps. Yep.
Good. Okay, so you now went to the pendant drop mode, right?
That's right, because I'm trying now to do a surface tension measurement.
Okay. Do you need to have this platform there for the surface tension measurement?
I don't really need it, and it can be easily removed because we're using like only these magnets.
So if somebody's just interested in surface tension measurements, essentially there is no need for this platform. The setup would be simpler.
No, you just remove it easily like this, and then we continue only with the pendant droplet and only the needle in place.
I see.
And again, we can start a new project, give it a project name. And again, the calibration is also needed for this, for this pendant drop. So I know the needle is 1-2 millimeters. Again, it's water and the atmospheric air. Gravity is the same. We're still on Earth. So I'm going to keep these the same.
Right.
And start.
The water they have is not strictly a kind of DI water.
No, it's just
sampling.
Exactly.
Demonstration. Okay.
That's right. So I hit capture again, fix it.
Upside down.
Upside down.
Similar to
Try to see where the needle is. We only really need to see the needle.
Right. The tip of the needle.
The tip of the needle.
Okay.
So here is good. I need to adjust focus.
That's good. They're all easily done there. The focus.
It's very easy, very convenient to play around with the image processing part. So now I have a sharp edges of the needle.
Okay.
So At this point, we are going to dispense some of the liquid, and what we're trying to obtain is to have a large drop as much without detaching.
Well deformed.
Well deformed, because we want to see the deformation of the gravity, because it's a balance between the surface tension and the gravity. So that's, the bigger it is, the better the algorithm is going to work. So now I have the zone of interest. I try to keep it around the droplet to have more of resolution to solve and not get any noise. Now I add the multi capturing.
Okay.
So I add 30 images within maybe 30 seconds, and I can hit capture.
You can keep on increasing, and you're making a measurement in the air.
Exactly.
And in the liquid as well, right?
That's right. Trying to have the droplet very deformed under its weight.
They should not be shaking, right? Or
Yeah.
Because you have multiple droplets, I think should be fine.
I have multiple
images,
snapshots,
should be
yeah.
fine. Okay.
So now I have a lot of snapshots that I can choose from. So maybe I choose this one, and I can go up, try to calibrate the needle. So now it's in green, so we're in good shape. And then we hit calculate. So now it gives you the surface tension of the liquid.
I see.
So here it tells you the volume in microliters and the area.
Which area? That's
Exactly,
interesting.
and
For surfactant type studies, you often would like to know the surface area of the interface as well. So it gives it to
That's right, and it's very quick and
right,
simple.
just in an instant. And you didn't do any Wi-Fi or connectivity for this thing?
Not at all. This whole thing is done offline, just tracking the edge of the
But
droplet.
again, you can sort of have all the data from multiple images in one convenient file.
That's
But
right.
If you want it's on the phone, or if you connect to the internet, then you can
even upload it on a
or
cloud.
whatever.
That's right. You can upload all the data in the cloud and just save them, access them anywhere.
Okay, very good, nice. Okay, very good. So you put a new surface here as well?
I put a new surface because I also added the tilting table.
Oh,
We wanted to see
when you
how we-
opened it up, I saw that one. Mhm.
That's right. So we're trying to tilt the surface, make the droplet roll off, or move on the surface so we can measure the advancing and receding contact angles
And also the sliding angle you get.
and the sliding angle for sure.
Okay.
So
App for that in this?
there's an app dedicated for this. It's the tilted app.
Uh-huh.
So we're gonna repeat the same thing. We're gonna
Add a new project.
I have my account already.
Uh-huh.
So I'm just gonna log in, create a new
Yeah,
project.
researchers can have separate accounts that are using this one, right?
Exactly.
Data is separated and firewalled against one another.
And only each account has access to their own projects.
Okay.
So we're gonna call this test, new project, and we start and we hit on this, hit in, and then we have the camera app rolling.
Again, upside down, inserting it in.
Yeah.
Nice Google Pixel phone.
Yep. So now we're really trying to keep the needle a little bit far left on this side to make the droplet, and then the droplet is going to roll off. So we want to make sure that we are adjusting this as well. Exactly. So we have to pay attention to where we're shooting. So I'm gonna adjust the focus again.
I like that there are many adjustability options.
Yeah, you basically can move in all directions, and you can move each piece separate. So I can move this needle a little bit because we're a little bit out of the zone. I can move it a little bit to the side. So now I have it, and then I can only move the phone. So I'm gonna get the needle closer. And then I can depose it large drop.
Well, you can control the size that you want to look, right?
You can manipulate by the needle size and how far you.
Syringe size. You mean? Okay. Make a nice large droplet to see what happens. You can even drop it on it. I don't think it really matters.
Okay. So now I have a droplet on the
Want
surface.
to make it larger a bit, just for better visibility in making the video. You have to be conscious of not to become too large, right, to get out of the viewing area.
That's the beauty of the automatic dispensing one.
Okay.
So you can easily manipulate this. So now I can move this a little bit to the side. So when I tilt, it starts to...
You just turn that knob in this manual version. Right?
Exactly. So I turn this knob either way. I can tilt in this direction. And I try to make sure that when I tilt it, I'm going to be stay inside the zone of interest.
Okay. The camera for phone.
So now I start again tilting until the droplet starts getting close to moving, and then I can use the multi snapshot feature again to be able to take as many snaps
As necessary.
Exactly.
You're almost getting there. The drop looks like it's ready to.
Okay, so I'm going to start the multi
Yeah, maybe
snaps.
seconds.
Can even do it for longer, maybe 40
Okay.
images for 40. Let's record.
Oh, I see movement.
There we go. So now we'll start it to move.
Very nice.
Perfect.
So
So now since it started to move, we're gonna be able to get the advancing receding
and
and sliding
yeah.
contact angles. Yeah,
So you get three pieces of information: advancing, receding, and also the sliding angle.
that's right.
Okay.
So now I have all these snapshots,
Okay.
and I can choose the snapshot where I have the droplet starting to move. Let's say, yep. So now the app actually adjusted it.
Oh, automatically it levels the platform.
It levels
Get
it.
the sliding angle or the
That's
platform angle.
Exactly. So it tells you the platform angle, and you can also adjust this bar. These
Nice.
sliders.
I need to calculate. Very
And then
good.
you have the right angle, which is going to be the receding. The left
Advancing.
sorry, the advancing angle, and the left one is going to be the receding one.
And you have the angle that droplets start to slide on, just 19 degrees.
Exactly. That's going to be the sliding angle.
Very cool. It was pretty quick too.
That was very
You
fun.
can do the same series just by a number of images that you have had. It's the
Exactly.
same
So
calculations.
I can go back
Okay.
and actually hit calculate, and it's going to do the whole for all these
Oh, I
images
see.
that I
So
have.
you're in the view that it's all of them. It's very cool. And you can select and deselect if you want some of them not to be
Yeah, you
not
can-
to be measured.
You can select some of them and delete what is not capturing, or the ones that already after the droplet rolled off.
I see. Oh, that's very
So
interesting.
you can easily manipulate. Yeah.
Okay, very good. Thank you.